Okay, guys. Oops. So we continue. Okay, this is section 6.6, video 2. Okay, in video 2, I'm going to solve two equations. We're going to solve exponential equations that is quadratic in form. Okay, and I'm going to use problem 57 from page 466. So this is what we need to solve. We have 2 to the power of 2x plus 2 to the power of x minus 12 equals 0. So this is quadratic type equation. And you're going to see it in a second because I'm going to rewrite it. So first of all, I want you to notice that 2 to the power of 2x, you can rewrite this as 2x to a second power. Okay, because let's review. Power of power property. For exponents, when you have x to the power of n and then to the power of m, this is the same as x to the power of m, then to the power of n, which is the same as x m times n. So in our case, you guys have 2 to the power of 2x, which can be rewritten as 2 to the power of 2, and then x, which is the same as 2 to the power of x, and then square. Okay, plus 2 to the power of x minus 12 equals 0. So now what you guys going to do, the middle exponential expression, we're going to use the substitution. So we're going to substitute 2 to the power of x with t. So we can recognize that this equation will become quadratic. That will be equivalent to t to a second power plus t minus 12 equals 0. And now we're going to solve quadratic for t. Now, a couple things when you're using that substitution, just put it on a side. You guys by now should know that 2 to the power of x, it's always positive, which means that t has to be positive. So when you will be solving the quadratic equation for t, you're only going to take the solution which is positive. So we're solving equation t squared plus t minus 12 equals 0. Let's factor this. I'm going to use AC method. A is equal 1, B it's a coefficient of t which is 1, C it's equal negative 12. So find two integers which by multiplication will give you AC which is negative 12, and the same two integers which by addition will give you B which is 1. So we're going to have 4 and negative 3. So now we're going to rewrite t squared plus t minus 12 as t plus 4 times t minus 3 equals 0. And now we're solving two equations. T plus 4 equals 0, or t minus 3 is equal to 0. So that will give us t is equal negative 4, t is equal positive 3. Now, I mentioned to you guys that negative solution, you're going to ignore it because t has to be positive, because technically t represents 2 to the power of x. So we're ignoring negative solution. t equal 3, it's correct, but this is not your final answer. Don't forget that we use the substitution. You need to solve the exponential equation, and our variable is x. So we need to solve for x. So t, it's 2 to the power of x. So now substitute back, and we know that t is the same as 2 to the power of x. So 2 to the power of x is equal to 3, and we need to solve for x. So this is an exponential equation. So the way we solve exponential equation, we change into logarithmic equation. So we're going to attach log of base 2 because base of exponent is 2. So log of base 2 to both sides. And now base of log is the same as base of exponent, so that cancel, and we end up with x equal logarithm of base 2 of 3. And this is our answer. I want to do one extra example. Exponential equation is quadratic in form. So we're going to do number 59 from your textbook, section 6.6. We have 3 to the power of 2x plus 3 to the power of x plus 1 minus 4 equals 0. So a couple of things what I want you to do. First, we're going to rewrite 3 to the power of 2x as 3 to the power of x and square. So we're building that quadratic. Now 3 to the power of x plus 1, so let's review. 3 to the power of x plus 1 is the same as 3 to the power of x times 3 to the power of 1. So here we have product property for exponents. So sum of exponents is the same as the product of exponential expression of the same base. And to simplify that, this is the same as 3 to the power of 1 times 3 to the power of x, which is just 3 times 3 to the power of x. So again, 3 to the power of x plus 1 is the same as 3 to the power of x times 3 to the power of 1. 3 to the power of 1, it's 3, and 3 to the power of x, we keep it. So I'm going to rewrite this as 3 times 3 to the power of x minus 4 equals 0. So again, I explain it how I convert that. So now change to, let's use the substitution. So substitute 3 to the power of x, make that equal t. The same thing, remember that this is always positive. So we'll be solving quadratic equation. T squared plus 3t minus 4 equals 0. Factor. So a is equal 1, b is equal 3, c is equal negative 4, a times c, it's 1 times negative 4, which is negative 4. So find the product of two integers, which gives you ac, just negative 4, and the same two integers by addition has to give you b. In our case, b is equal 3. So what's going to work? 4 and negative 1. So now we're going to rewrite t squared plus 3t minus 4 as t plus 4. Again, that was the first integer, times t minus 1. That was the second integer, which we find by using AC method of factoring quadratics, equals 0. So we're solving two equations. T plus 4 equals 0. T minus 1 equals 0. We're getting t equal -4, t equal +1. Don't forget, negative solution, we ignore it. Again, we're ignoring that because t represents 3 to the power of x, and that's always positive, okay? T equal 1 is correct. Now we're going to substitute back. So t is the same as 3 to the power of x equal 1. Okay, and now we just need to solve for x. I'm going to solve it using one-to-one property. I'm going to convert 1 to 3 to the power of 0. And now, using one-to-one property, that will just give you that x is equal 0, and that's our answer. Okay, so this is the solution. Again, note, you could also solve this 3 to the power of x equal 1 by attaching log to both sides. So you can convert, if you want to, you can convert to logarithmic expression. So to do it, you will attach log of base 3, because base of exponent is 3, to both sides. Okay, however you guys like it better. So here that will cancel because base of log is the same as base of exponent, and we end up with x equal log base 3 of 1. And log base 3 of 1 is 0. Because I want to review here the property. It was the property log of base a of 1 is always equal 0. Okay, so it doesn't matter how you're solving, you're still getting the same solution, which is 0. Okay, so that's it of section 6.6. I know it's a lot. Practice, practice, and one more time practice. And let me know if you guys have any questions or if you need help with anything. I'll be happy to do it for you and help.